Professor Ray here. One of my viewers was corresponding with me this week, and they said, you know, with this coronavirus going on, and this is when I'm shooting this video during the coronavirus, it'd be a good opportunity to talk about exponential growth, and specifically things like arithmetic series and geometric series. So today I'm going to do a couple of quick demos. We're just going to go over this to give you a little bit of context for what an arithmetic series is, a geometric series, and how a virus like the coronavirus can take off uncontrollably in a geometric series type event. And the way I'm going to do that is actually with a checkerboard and a whole bunch of pennies. And what you're going to find out is I don't have near enough pennies in this house to fill this checkerboard the way I want to. So enjoy the ride. I think you'll learn a little bit about this and help give some context as to what we're seeing. So what I'm going to do is use some pennies to build an arithmetic series on this checkerboard. And here's how we do that. I'm going to put 1 penny on the first square. Now I'm going to add 1 penny for each square. So that would be 1, 2 on the second square. I'll add 1 penny. That would be 3 on the third square. I'll add 1 more penny. That would be 4 on the fourth square. And I'll add 1 more penny. And that will be 5 on the fifth square. And rather than bore you with putting all these together, we'll come back in a minute after I've had a chance to put these pennies on this board. And you're going to find out that this jar of pennies, which is full, is not going to go very far on this board. But this is the arithmetic series. We're increasing by adding a constant value. We're adding 1 penny. So we go 1, 2, 3, 4, 5. We'll go all the way through until we get to square 64. So here we have the end result of our arithmetic series. Remember, we started with 1 penny on square 1, then we added a penny for each square. So there were 2 on 2, 3 on 3, 4 on 4, 5 on 5, etc. And had we got all the way to the end, we would have had 64 pennies stacked on the last square. I stopped at number 41 because that's all the pennies I could find in the house. But it gives you an idea of how the amount increases in an arithmetic series. And in fact, I have that displayed on this graph. And it shows that it's a straight line, at least on these axes. These are linear axes on this graph, and that's a straight line. Later, when we talk about the geometric series, I'll show that, and then I'll show you how we have to plot that on a different axis if we want the two sets of data to be visible on the same graph. But this is the arithmetic series. Like we said, we add a constant for each one. And in this case, it's 1 penny. We would end up with 2,080 pennies, $20.80, had we been able to fill all this out. The arithmetic series. Now let's look how a geometric series works. Remember, the arithmetic series, we added for each square. In the geometric series, we're going to multiply by some factor. And in this case, I'm going to multiply by a factor of 2. So that means I'm going to double for each square. So let's start a few out. 1 penny on the first. We double it. We have 2 on the second. We double that. That means we have 4 on the third. We double that. That means we have 8 on the fourth. And if we double that, we'll continue. We'll go 16, 32, 64, 128, 256, 512, 1024. And you're going to see that these numbers absolutely skyrocket when you use a geometric series. And the geometric series is also called exponential growth in some cases, and it's what we see when we see like a pandemic like coronavirus, but it's also used in other applications. For example, control of a nuclear power plant. We try to suppress the neutrons because they will take off exponentially. So we very tightly control the neutron release to release the energy to generate the power in a nuclear plant. So this geometric series applies to lots of different science, technology, engineering, and mathematical processes in many different industry sectors. But let's go ahead and we'll cut back and see how our geometric series starts coming together. So here I started building the geometric series, and what you'll notice, I stopped really quick because these stacks of pennies are going to get out of hand and get tall really quick. In fact, it's reflected on this graph that I'm showing on the computer monitor, and that graph is a little misleading because there are so many pennies at the end that we really don't see what's going on up front, even though we're getting dramatic increases. So using a factor of 2, here's how this progression goes. 1 penny, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024, 2048, 4096, and we would just keep on going till we got to number 64. And the stack is incredibly huge at 64. It's actually pretty inconceivable. And if I took all those pennies together and I added them up, the dollar value would be, I have to read this one because it's so big, 184 quadrillion, 467 trillion, 440 billion, 737 million, $96,000. That's how much would be stacked up here. And if each penny is 0.598 inches thick, that means when we get to this end, this stack is roughly 8,704 billion miles tall. Now, the distance from Earth to Pluto is about 3.2 billion miles. So this stack just goes astronomically out into space. And this is what happens. This is why we worry about geometric series when we talk in terms of pandemics, because things can get out of hand very quickly and start to take off in a geometric type series like this. And we get this response that we see on the computer monitor. So I've got some more calculations put together, and I'm just going to go focus on the computer monitor in a minute, and we'll just look at a couple of quick graphs to help reinforce this difference between arithmetic and geometric series. So just to do a quick review of what I did, over here to the left, I have the square number on the checkerboard, and there are 64 squares total. Using the arithmetic series, I have 1 penny, then 2, then 3, then 4. And when I get to the very last square, I'll have 64 pennies. If I add up all the pennies on the board as we go, we come down here, and we have 2,080 pennies, which is $20.80. And if I plot these on a graph, we see a straight line for the arithmetic series. So we go from 1 to 64, and we do that as we go across the 64 parts of the checkerboard. Let's go ahead and look at the geometric series and see the difference. So again, we have the 64 squares right here shown. But now look how the geometric series goes by multiplying by 2. We go 1, 2, 4, 8, 16, 32, 64, 128, and we get down here very quickly, and notice these numbers have e's with pluses at the end. This means we're using scientific notation, and that's how many zeros are behind these numbers. So now we're up to 12 zeros behind the decimal point, or 12 numbers behind the decimal point. And down here we're up to 18 numbers behind the decimal point. And if we go through and we add up all the pennies, take all the squares and successively add the pennies, this is that huge number we get for how much money is on that last square. So let's do a quick comparison, and I'm only going to go square 1 through 8, just the first row. The arithmetic series, we go 1, 2, 3, 4, 5, 6, 7, 8. The geometric, 1, 2, 4, 8, 16, 32, 64, 128. And if I graph those, you see the difference. The blue line is the arithmetic series, and it's very slowly changing compared to the geometric series, which starts to take off and rapidly expand. And this is what happens when we have a pandemic situation. We have this rapid expansion. If I plot these together on a linear graph, and this is for all 64 values, notice we can't even see the arithmetic series. It's so small compared to the geometric series, and then we see this knee in the curve where the geometric series just starts to take off astronomically. If I plot that on a graph that has a logarithmic axis for this axis, what we see is the arithmetic series comes up and tends to plateau off like this, but the geometric series becomes a straight line on a logarithmic graph. So I hope that helps explain the difference between arithmetic and geometric series. And with the current coronavirus pandemic, maybe you have found this information enlightening and useful. This is Professor Ray signing off.
Thank you.